as much as needed, on demand. Now, that meter's a very careful accountant. It registers the amount flowing in, hour by hour, kilowatt by kilowatt, and displays the total on a series of dials. It uses this flow of electricity to produce magnetic fields, and these magnetic fields create movement. With this movement, the meter can display the amount of electricity consumed. Huh? How does it do that? First off, the parts we see. A spinning disc that moves a set of dials. These dials display the amount of electricity consumed. The more electricity being used, the faster that disc spins. That spinning disc runs the whole show, with the help of electromagnets. To find out how means looking at the parts we don't see. It's time to break it. Inside the meter, there's the all-important aluminum disc. It connects to a spindle. That connects to gears that slowly turn the needles on each dial. Above and below the disc, copper coils. First step, electric current enters the meter through two wires, then races to the coils. This current changes direction 120 times per second. It's what's known as alternating current. When that alternating current enters the coils, they become magnets, electromagnets. That's a law of electromagnetism. Now, these electromagnets each generate a magnetic field. And because they're the result of an alternating current, these fields also change direction 120 times per second. This change in direction is key. Why? Well, when a magnetic field changes direction near a material that conducts electricity, current appears in that conductor. That's another law of electromagnetism. The disc near the coils? Aluminum, a conductor. So now there's electric current in that aluminum disc. On to the next step. When electric current appears in the disc, it creates a magnetic field that surrounds the disc. This is where the magic happens. The magnetic field around the disc interacts with the magnetic fields coming from either of the two electromagnets. When that happens, presto, that interaction turns the disc. Okay, it's not really magic, it's physics. When the magnetic fields interact, they create a force that extends in one direction only. That's the force that rotates the disc, in one direction only. Now, the speed at which that disc turns is in direct proportion to the amount of electricity being used. The more electricity that flows into the meter, the greater the force of the magnetic fields. The greater the force, the faster that disc spins. As the disc turns, it rotates a spindle. That spindle moves a set of gears that turn each needle on the dial. They precisely display each kilowatt of electricity that's being used. Incredible. It's a chain reaction. Magnetic fields that generate an electric current. That produces another magnetic field. Together, they create motion. That represents precisely the amount of electricity consumed. The electricity meter. Simply amazing. It uses the flow of electricity to generate movement that precisely illustrates the amount of electricity that's being used. Each time that disc makes a complete turn on itself, it means enough power has flowed in to light a 100-watt light bulb for about 4 minutes. And all those turns of the disc add up. The electricity meter, a brilliantly simple and accurate device behind every electric bill. Next on Deconstructed.